Okay, hello, welcome to another Ginger Mathematician video. So this is the last version of this paper for May-June 2018. This is the 2-2 paper, the one I haven't covered so far, and we are going to go through this in the same way. I'm sporting a new haircut. Let's get on with going through the paper. I like to look at the examiner's report, as you know, and this is it here. So not much to be said really. Most people show good algebraic skills, but some people didn't know how to convert minutes into hours, so that's the important skill we'll look at later. And some people made careless numerical slips. You see this is a common theme with the examiner's report, people making these silly mistakes. It's a really important skill to make sure you can actually check your working as you go through. Okay, and question 1 is a very good example of that. So just before we start though, just some general marking principles that as an examiner, this is the way they're going to go about marking. So you can see here that most of it is quite standard. Marks awarded are always whole marks, so no half marks, for example. Marks must be awarded positively. Okay, so if I can see as a student you're on the right lines, I can give those method marks. Okay. Marks awarded when candidates clearly demonstrate what they know and can do. So marks are not deducted for errors or omissions. Okay, so if in doubt, write as much down on the paper as you can. So do keep that in mind. Right, so let's get to the paper itself. So this is the 2-2 paper, formula sheet as normal, and we get into question 1. So a quadrilateral has exactly, and that's the key word here, exactly one pair of parallel sides. Okay, so exactly means exactly one, not 2, not 3, but exactly 1. Write down the mathematical name for this quadrilateral. Now, I know some students, when they approach a question like this, the first thing they think of is this shape, which is a parallelogram. The problem is this has 1, 2 sets of parallel lines, which is a bit of an issue. So this doesn't have exactly 1, this has 2. So we need a shape that has only 1, and there's only one shape that exists, which has this feature, and it's this shape here, which you should all know is called a trapezium. Okay, so make sure you spell that correctly as well, please. Okay, I don't know why it's not working properly. Come on. Don't fail me on the very first question. That would be a useful thing. There we are. Okay, so usually you can double click these things. And the answer is trapezium. Okay, it was poorly answered. If you look at the examiner's report, a lot of people were putting either this parallelogram, which by the way is totally wrong. So this answer is not correct, but it's actually a trapezium. It looks like this. Keep that in mind. Okay, question 2. AB is a straight line. Find the value of x. Well, we should all know the angles on a line add up to 180 degrees. So the way we do this is you break it down into 2 steps. So step 1 is we do 41 plus, that's not being very helpful. Okay, that's odd. I don't know why it's not liking me doing this. Usually it's absolutely fine me doing this. Okay, apologies for the technical problem. Let me click on escape instead. Okay, let's get back in. Right, so there we are, 180. So let me just double click, it's usually easier. Right, so 41, let's get back to it, plus 76. So we add together the angles that we know. So that gives us 117, if done correctly. And then finally, we take the answer we just made, so 117, and we take that away from 180 degrees. And just be careful with your number bonds here. The answer will not be 73, but of course 63 degrees. Okay, so your answer there is 63 degrees. Okay, so just make sure you do the addition and subtraction carefully. It's 1 mark. It's a fairly straightforward mark to get. Okay, question 3. So a bag contains 2 blue balls, 3 red balls and 5 green balls only, so no other colours. 1 ball is chosen at random. Find the probability that this ball is red. So in order to do this, we write down, so P of red, well, the probability of red, how many red do we have? Well, we have 3 red balls, and then let's have a look, how many balls do we have in total? 2 plus 3 plus 5 is 10, and notice this is a 1 mark question, so there shouldn't be any simplifying, and there isn't here, so that's our answer, 3/10. If we look at our examiner's report for that question there, this question, very well answered. You could also write it as a decimal, 0.3. You'll notice on the mark schemes, if I actually go to the mark scheme now, that's not the mark scheme itself, question 3, you'll notice there's something here called OE. That stands for or equivalent in the code here. Therefore, if you had 30% or you had 3/10, both answers would be correct. Okay, so keep that in mind. Sometimes you'll see this OE as we go along. Okay, next one. Write down a prime number between 60 and 70. I try and work systematically on this. Well, we know 60 doesn't work because 10 goes into 60. So let's try the next number, 61. Now, one of the tricks to check a number is if you think of the square root of 61, approximately, the square root of 61 is going to be less than 8, okay, because the square root of 64 is 8. So the only factors we need to check are between 1 and 7. So as long as we just check between 1 and 7, then we'll know we've covered every number that could go into 60. So 2 doesn't work because it's not even. Now 3 doesn't work because 6 plus 1 is 7 and 3 doesn't go into 7. 4 doesn't work because 2 doesn't work. 5 doesn't work because there's no 0 or 5 at the end of this number. And 6 doesn't work because 2 and 3 both don't work. 7, you can check your times tables. 8 times 7 is 56. 9 times 7 is 63, therefore 7 doesn't go in, therefore we found one prime number. It's not the only answer, 61. I think, if I remember rightly, there's a couple other answers. 67, I think, is acceptable as well. Yeah, you can see 67. You can do the same analysis on that as well. So, nice start to the paper. A lot of people got question 1 incorrect, so please do revise your 2D shapes. Let's move on. So question 5. So we have a standard linear equation, come up quite often on the paper too, and we just need to go through our steps nice and carefully. So we want to get all the x's on one side. So what's the opposite of the smallest amount of x? So the opposite of 5x, well, we're going to minus 5x from both sides. So I'm going to minus 5x from both sides. 7x minus 5x, well, that is 2x. The 9 stays the same. And then we look at the right hand side. 5x minus 5x cancels, and 17 is left. And now we've got an even nicer equation, and we just work through the steps steadily. So what's the opposite of the smallest number? Plus 9. Well, then we want to minus 9 from both sides of the equation. So 2x stays the same. 9 minus 9 cancels. And 17 minus 9, well, that will give us 8. And from there, if 2x is equal to 8, well, 2 times something is 8, x must be 4. And that's our answer. X equals 4. Okay, nothing much really to talk about in the examiner's report. Question 5, nearly every candidate obtained the correct answer. So not a very good discriminator in this case. Okay, let's keep moving on. So question 6, write 36 as the product of prime factors. As soon as you see that phrase, a product of prime factors, we're going to need to draw, a factor tree. Okay, so that's a key signal. You need to draw a factor tree. What do I mean by this? Well, we start with 36. We find two numbers that multiply to give you 36. And it doesn't matter which those numbers are. We'll all get the same answer at the end. So I'm going to go with 6 times 6. You could do 18 times 2 or 9 times 4. Many possibilities. Now, because these numbers are not prime, I keep breaking them down. So let's have a go at 6. Well, 6 is the same as 2 times 3. 2 is prime. 3 is also prime. Let's look at 6 over here. Well, it's the same thing. We have 2 here. We have 3 here. So that's prime. That's prime. So our answer will then be 2 times 2 times 3 times 3, which I know some of you will write the answer in a slightly different way. 2 squared times 3 squared. Okay, and we're done. Both answers are acceptable in the mark scheme. So if you go back to the mark scheme, you'll see both those answers are allowed on that question there. Quick flick on the examiner's report. Okay, some didn't write it in the correct form. I've noticed some people put pluses rather than multiply. Please do avoid that. That's an easy mistake to make. Okay, back to question 7, which is now solve the inequality. Well, we approach it in the same way we did question 5 up here. So we just minus and add on both sides. So let's start with this. Well, we want the x on its own. So what's the opposite of plus 7? Well, that is minus 7. We do that to both sides of the equation. If we do that, well, 3x stays the same. Plus 7 minus 7 cancels. 1 minus 7, well, that's equal to minus 6. Careful with negatives. So we have 3x is less than minus 6. And then we want to get x on its own. The opposite of timesing by 3. Come on, what a dot, that's it. Is dividing by 3. That's it. So this cancels with this to give us x. The less than sign hasn't changed. Because we haven't divided by a negative number, this symbol stays in the same orientation. And minus 6 divided by 3 is minus 2. So when you write your solution, make sure you put the inequality sign as well. X is less than minus 2. Even if you think of it like an equals, you must write this symbol right at the end. Okay, so x is less than minus 2. There we are. And let's see what they said on this part here. Most candidates scored both marks. Common error was changing the sign even though there was division by a positive. So what I mentioned earlier, the sign doesn't change unless you divide by a negative number. Okie doke, so all good so far. Let's have a look at question 8. So point A has coordinates 2, 12. Point B has coordinates 4, 2. Find the coordinates of the midpoint of AB. So what we want to do is compare like coordinates. So these are the x coordinates. And then we want to find halfway between them. So to find halfway between the x coordinates, we add the two numbers together, so 2 plus 4, and then we divide the answer by 2. We're finding the average of the two numbers, if you want to put it that way. And I'm sure we see 4 plus 2 is 6. 6 divided by 2 is 3. So that's the coordinate of the x-coordinate of our midpoint. So that can go here. And then we do y in exactly the same way. So let me change pen colour. Hopefully. I can't see it. Okay, doesn't matter. So we take the 12 this time and the 2, and we do the same process. So we do 12 plus 2, and then we divide by 2. Same process. So 12 plus 2 is 14. 14 divided by 2 is 7. And we get the second coordinate, 3, 7, for our 2 marks. Okay, so let's have a look at the mark scheme. 3, 7, 1 mark for each coordinate, and the examiner's report. Most candidates scored full marks. It's quite a high boundary on this paper for a C. It's 24 marks out of 40, so you can see a lot of students did very well. Some students found the gradient rather than the midpoint, so that's a common mistake. Okay, so next question is very common lower down in your career as a mathematician. So you do this a lot when you're 12, 13 years old, and working out the fractions here and the subtraction. So first of all, we convert this into an improper fraction. So 5 times 4 is 20. 20 plus 2 is 22. So as an improper fraction, this is 22 over 5. We do the same process here. So 1 times 3 is 3. 3 plus 2 is 5. So this becomes 5 over 3. And now we find our common denominator. So here it's 5 and 3. So 5 times 3 is 15. So let's write this in terms of 15ths. There are other possibilities too. And then in order to work out what goes up here, well, we need to multiply the 22 by the 3 and the 5 by the 5. There are different ways of doing this. So this is 66 because 3 times 22 is 66. 5 times 5 is 25. And don't forget this is a minus problem. So make sure there's a minus here. And then finally, we just have to subtract the numerators. So 66 minus 25, well, that will give you 41 over 15, which, if you so wish, can put this into a mixed number. So that gives you 2 and 11 over 50. I think both answers are acceptable, if I remember rightly. Question 9, yep, both solutions are correct, and you can see you pick up method marks for different parts of it. So 1 mark just for the common denominator, 2nd mark for getting those 2 numbers at the top and then taking away. Very good. Okay, let's keep moving on. So far, nothing too tricky in this paper. Everything's, again, very, very attemptable, very doable. Okay, question 10. So we're going to use the cumulative frequency curve to estimate the interquartile range for 2 marks. Okay, well, if we look at our data, our cumulative frequency goes all the way up to 100. Now, strictly speaking, to work out the lower quartile, so you might see this on your calculator as well. So this is your lower quartile, Q1, and your upper quartile is known as Q3. Now, to work out where we actually read off the graph, now some people will add 1 and then you divide by 4. That's what you should do. On this particular graph, it might be easier to not do that, to just read it off. But you should do 100 plus 1 divided by 4 for the lower quartile. strictly speaking. And if you do that, well, 100 divided by 4 is 25, so it's going to be the 25.25th value. Now, as you can probably imagine, it's going to be very hard to distinguish between the 25th and 25.25th value. So I'll put val for 25th value. So when you come to read the graph, remember this goes up in twos, yeah? 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So if you go to 25, 2, 4, 5, it's right in the middle of this box here. So I'm going to draw a line all the way across. My line's quite thick. You should be able to see this. I hit the line there. And so I read off my graph at this point here. This will be my lower quartile. So let me see where I can put that. Let me put it over here. So Q1 is going to be whatever that coordinate is there. This scale goes along in ones, so 10, 11, 12, 13, 15. So my lower quartile will be 15. And I do a similar process for Q3, but since we've worked at the lower quartile, I just times whatever Q1 was by 3 to give me 3/4 of the data for the upper quartile, and that gives me the 75th value. Okay, there we are. So then we go up to the 75th value, or 75.75th value. So 62, 64, 68, 62, 64, 66, 68, 70, 72, 74. So it's here. So if I read off the graph here, hopefully you can follow my horrible line going across. There we are. And then we read down from that line there. You can probably do this better without a computer actually. And then we read off that line, well, 31, 32, 33, 34. So Q3 will be 34, like so. And therefore our answer to the question, the interquartile range, well, it's the difference between these numbers. So let me get a text box up. So to find the difference between these numbers, it's 34 minus 15. Just check that, 34 minus 15. Good, and that's going to be equal to 19, if I'm not mistaken. So your answer will be 19. Now let's see how friendly they are on the grey boundaries. You can see they do expect you to read off the exact value there. Okay, there's not much room there for going away from that line. So you've got 20, you've got 18, you need to be absolutely spot on with doing that process. 1 mark for finding either 15 or 34 separately. Let's see what the... Okay, someone did it the wrong way round. Okay, so make sure you start at your cumulative frequency and then you work your way backwards to working out then the x value there. Okay. Nth term, right, so this comes up quite often. Please look at my other video where I predict what's going to come up on May 2019. I'm quite excited whether I'm totally right or just mostly right. I'm being very positive there. So first 4 terms of a sequence. Write down the next term. Well, if we look at our sequence, this is going down, in 4s. So it keeps going down in 4s. So the next number will be 1 minus 4, and 1 minus 4 is minus 3. So just check the pattern. That's quite a nice question because it's linear. So to work out the nth term, we take what we just did here, so the common difference. So I'm going to write this in a kind of weird format, un. So un is equal to minus 4n, like so. And then we look at our difference. what do you do to minus 4 to get to the first term of the sequence 13? So what do you add to minus 4 to get to 13? Well, that is 17. And you can check that 17 minus 4 is 13. So that's our answer there. Okay, so let's have a look at the mark scheme. Okay, they've written it the other way around, 17 minus 4n. But remember, you've got that OE there, or equivalent, so both answers would be correct. Okay, 1 mark for either noting the difference is minus 4, or that you start at 17 with the sequence, whichever way round that is. Okay. Yep, so some people wrote it that way round. But lots of people are doing very well on this paper, so it puts a bit of pressure on all students then to get as many marks as they can. Okay, we haven't had a Surd question yet, and it always comes up, iGCSE, so this is a simplifying question for Surds. So you've got root 75 minus root 12 plus root 27. So whenever you're adding surds or subtracting surds, you want to simplify them as much as you can. So if we take our first surd, we want to look at square numbers that go into that number. So have a think, what square number goes into 75? Okay, hopefully you noticed that 75 is the same as 25 times 3. So we're going to rewrite our first surd as 25 times 3. And the reason we've done this is that we can now split our surd into the square root of 25 times the square root of 3. So that's the purpose of writing it like this, is that we can split it, and then the square root of 25, well, that's equal to 5, and the root 3 stays as it is. Okay, now we're going to approach the next questions in exactly the same way. So the square root of 12 is the same as the square root of 9. Oh no. I'm talking about the square root of 4 times 3. So the same process. Now if this is to work, they should have a surd they share, which they certainly do. We split this now into the square root of 4 times the square root of 3. And then we all know that the square root of 4 is 2. So this becomes 2 root 3. And if we were to do a similar process for the square root of 27, so if you work through that yourself, you should get the answer of 3 root 3. So I won't go through every little step there, but you should get 3 root 3. And now we just collect up like terms. So if I gave you the problem, so let me do this in a text box instead. So if I gave you, it's definitely there, come on. It's like it's trying to fight against me. Okay, I'll just use the pen instead. So if I was to give you a similar kind of problem, so 5a minus 2a plus 3a, a lot of you will be able to tell me straight away it's 6a. And we approach this in the same way. So we do 5 root 3 minus 2 root 3, that's 3 root 3, and then 3 root 3 plus 3 root 3 is then 6 root 3, which is then our answer. So we get 6 and the square root of 3 as our answer. Okay, so you can write that, of course, as 6 root 3. A lot of people find that last step difficult, yeah? 5 root 3 minus 2 root 3 is 3 root 3. 3 root 3 plus 3 root 3 is 6 root 3. Okay, and we're done. And you can see you get separate method marks for simplifying each surd separately as well. Good. Okay, examiner's report. Most scored full marks. Some found 0 as the answer because they thought about BIDMAS. I think this is the problem. So whenever you have adding and minusing, you work from left to right. So don't think you have to do the adding first necessarily. So that is an important point that's made there. And I've noticed some students do that mistake. Okay, right, on to Venn diagrams. If you've been watching my videos, you know this is definitely not my favourite topic in the world, but let's go on. So, shade the given set in each of these diagrams. Okay, now the key points here are these symbols here. Now this here means the intersection, so what they share essentially. Okay, you can think of it as and, but that sometimes doesn't help you as well. So first of all, we think of everything that's not A. So everything that's not A, that is basically everything outside and this part of B. Okay. Now we also want and B, so we ignore the outside of our Venn diagram, and so we shade in this particular part here. And not including this because that's in A and we're not allowed to be in A. So I'll talk that through again. So not A is essentially the outside of our Venn diagram and this part of B, but the second instruction tells us to have and B as well, so we ignore the outside and just include this part here. That's a little different to the union, which is what we're going to look at in the second question, which is a bit trickier. So this means essentially the union of the two things collected together. That's an important point I'll make a point of later. Sometimes you can think of it as or as well. Sometimes that helps. Okay, so first of all, we need to think of everything that's not A. Okay, so not A is everything. So similar to the first question we did. So if I shade in everything that's not A, I'm just avoiding going into A, but I'm shading in everything else. Notice it's both this part of the Venn diagram and the intersection that's not shaded in. Makes kind of sense. Now we've got or not B. Therefore we have to basically make sure we shade in everything that's not B. Okay, now we can't shade in the middle part because we said not A already. So we're going to now shade in everything that's not B, which is now this part as well. I mean, I could do the outside again, but I've already shaded the outside. So the only part I haven't shaded is the inside part. Now the dash at the end says not that. So this is my diagram. So the answer I've done here, I've shaded in the region A or not B. That's what I've shaded in down there. So I've missed out this part here of my Venn diagram. But I've shaded in everything else. Now, because we want not what I've just shaded in, we get rid of everything apart from the center. So the actual answer will be, I'll need to try and find a rubber, so this is a new experience for me. Yeah, I've got a trackpad, that's nice to know. I don't know how I shade it in. Maybe I have to go to undo or something. Right, so if I just undo everything I just did, might take a bit of time. There's probably an easier way of doing this. Please write in the comments how you do this. But essentially your answer will be just the part in the middle shaded in and nothing else. So I'll show you in the mark scheme, that might be quicker. Yeah, so your actual answer will be the opposite of what I did, because looking for not it. So actually this part is the only part that's shaded in your Venn diagram. Okay. So let's go back to this. Yeah, second part was more challenging, and candidates are to be commended for their very clear shading. So well done for shading it in completely and not doing it in a rush. Very nice. Okay, on to question 14 now. So getting towards the harder end of the paper. And it's a coordinate geometry question, and quite a typical one as well. So you're given 2 points. So point A is coordinates 2, 3. Point B has coordinates 4, 11. Find the equation of the line AB. Give your answer in the form y equals mx plus c. Okay, so you have 2 coordinates, and in order to write any straight line, you need the m, that's the gradient, and you need the c, which is the y-intercept. So let's start with the gradient first of all, which is our m. Now to work out the gradient, you probably know this as the rise over run, or the change in y over the change in x. So to write it in a more formulaic way, we're going to take y2 minus y1 over x2 minus x1. That's the same thing as saying the change in the y-coordinate, the difference, divided by the change or difference of the x-coordinates. Now, if you did it the other way around with the coordinates, you'll still get the same answer. So it doesn't matter which coordinate comes where, as long as you do it consistently in the problem. So y2 minus y1, so y2 is this coordinate, 11, and y1 is this coordinate, 3. And for the bottom, x2 is 4, and x1 is 2. And we just do this calculation. So we get 11 minus 3, that's 8. 4 minus 2 is 2. 8 divided by 2 is 4. So the gradient of the line that we want is 4. So the basic form of our line can be written now as y equals 4x. So the 4 comes from the gradient, what we just worked out, plus c. So we still don't know the y-intercept. The easiest way of working this out is substituting one of these points. I'm going to take this point and substituting those 2 values for x and y into my basic equation. So I'll do this using a text box, probably a little bit quicker. So when x is equal to 2, y is equal to 3. So that's using that coordinate I just mentioned. So when x is 2, y is 3. Okay, well, what does that actually mean for our equation? Well, that means then that y is 3, so 3 equals 4 times x, well x is 2, so 4 times 2 is 8, and we still don't know what c is. So we leave that there, and then we work out what c is. Well, 8 minus something is equal to 3, therefore c must be equal to minus 5. Okay, you can check that. 8 minus 5 is 3. So our solution then, the answer to the question, why is it doing that again? It's almost like having a fit and going, nope, don't want to do it anymore. So it's being a little bit on the moody side today. Ah, there we are. Yeah, it just sort of freezes up every now and then. Right, so our answer then is y equals 4x, and now our y-intercept is minus 5, so the answer is y equals 4x minus 5. Strictly speaking, the y equals is already there, so 4x minus 5 is my answer. Okay, there we are, and this was generally well answered by majority candidates, and some were unable to do that substitution I did at the end. That's a good point. I find some students do struggle with the whole coordinate geometry section of the course. But again, these questions come up quite regularly, so worth practicing, and also for perpendicular bisectors. Okay, so expand the brackets and simplify. So we're going to use FOIL. So that's first, outside, inside, last. Many schools teach in different ways. Got box methods, got eyebrow method, there's all kinds of things. I'm going to do it the most classical way. So first, outside, inside, last. So we make sure we multiply everything. So let's start with the first one. So 3x times 5x, well that is 15x squared. Then we're going to do the outside. So 3x times minus 3y is minus 9xy. So that's the first eyebrow. Inside, minus 5y times 5x. Well, that's minus 25xy. And then finally, the last term, minus 5y times minus 3y. Well, minus 5 times minus 3 is plus 15, and y times y is y squared. So be careful of negatives. The only terms that we can collect together are those two middle terms together. So the 15x squared stays the same, like so. Minus 9xy minus 25xy, well, that's going to be minus 34xy. And the plus 15y squared stays the same, so you get plus 15y squared. Okay, and that's it. There's no extra factorising to do because they want you to expand. So let's look at our mark scheme. Yep, they've written it exactly the same way. Just be careful with those two middle terms to get that third mark. That's important. Errors made. Mostly good attempts. They're collecting like terms, those middle terms. And minus 25 minus 9 is not minus 36, it's minus 34. Please do get those negative numbers right. You can see how many students lose marks for silly errors. Really silly errors like that. Okay, now this is harder than it looks on the surface because it's not clear about replacement. A factory makes soft centre chocolates and hard centre chocolates only. The probability that a chocolate chosen at random has a hard centre is 0.6. 3 chocolates are chosen at random. Find the probability they are all soft centre chocolates. Okay, so what we're looking for essentially is the probability of soft, soft, soft. Okay, that's essentially what we're looking for. Okay, so the problem from this question is not clear whether there's replacement or not. Now, you have to take it from context. It's a factory, so they can have many millions of chocolates being produced at any one time, many thousands of chocolates at any one time. There's no information to tell you it has not been replaced, if that makes sense. So if you assumed it hasn't been replaced, we don't know how that changes the probability. We're not told. Therefore, you have to assume it is replaced, which is probably the most confusing thing about the question. So if we go back to what we're doing here, the probability of a soft chocolate, well, if the probability of a hard chocolate is 0.6, the probability of soft must be 0.4 because the factory only makes soft and hard centre chocolates. Now we want to work out the probability of soft and soft and soft. Remember, and in probability means multiply. So you need to take the 0.4 and then we multiply. Come on, 4, there we are. 0.4 and then we multiply by 0.4 again. And that's all there is to it for the answer. The trickiest part now is just to work out exactly what this is. Well, we have 3 decimal places in the question, so we need 3 in the answer. Now, you should know that 4 times 4 times 4, well, 4 times 4 is 16, 16 times 4 is 64. So we know that's in the question. And therefore, we need an extra 0 here, so there's 3 decimal places in the answer. 1, 2, 3, 1, 2, 3. And we know we've got the right answer. There, unfortunately, is replacement in this, even though it's not obvious from the question that there is. And also, the amount of marks they give you is a bit confusing. You'd expect to do more maths to get those 3 marks. So, yeah, not a very nice question. There's the answer, 0.064. I imagine the mark scheme will say something similar to what I said. Okay, most people realise how to cube 0.4 and struggle to work that out. And significant number of candidates who thought there was without replacement and tried to calculate this. I do have sympathy for that. It didn't seem obvious at all that you'd have to not do replacement. So I do have sympathy for those candidates, and it wasn't obvious from the wording of the question. Okay, final two questions on the last page. So question 17, we're to factorise this not very nice expression. And the way it's been structured and designed, it really wants you to split the term, which is a method not every school teaches. I'm going to teach it this question and do it in two different ways. I'll do split the term first, and I'll show you the way I tend to think of it instead. So in order to split the term, first of all, we take these two numbers, the coefficients of the first and last term, and multiply them together. So we get 4 times 3 is equal to 12. So far, so good. And then we write down all the factors of 12 that we know. Well, we've got 1, 1's factor of everything, 2, 3, 4, 6, quite a lot actually for a small number, and 12. And what we need to do is we need to find a combination of these numbers that add or minus to give us -4, this b term. Now, the one that comes out to mind straight away, maybe it's not the most obvious possibly, is -6 and +2. Okay, if you take those two factors, so this factor here and this factor here, and put a minus in front of it, you'll get -4. So what we're going to do is split this term into two separate terms, i.e. unsimplify it to make it then easier to work with. So let's write it up here. So you get, oops. Okay, so we get 4x squared. There we go. 4x squared. And now we're going to split this now. So we're going to get -6xy plus 2xy, and the -3y squared stays the same. Okay, so all I've done is unsimplified -4xy to -6xy plus 2xy. Why would we do such a thing? Well, what we're going to do now is we're going to factorize into single brackets. So we're going to do the two sides separately, and then you'll see what comes out of it is then easy to factorize. So what do these two things have in common? Well, they have a 2, but they also have an x in common as well. And then we think, okay, what do you multiply 2x by to get 4x squared? Well, that's going to be 2x. What do you multiply 2x by to get -6xy? Well, that's going to be -3y. Okay, so far so good. This one, well, the only thing they have in common is a plus y. So we'll put that outside, and we do the same procedure. So we then factorize into a single bracket. And you're probably noticing now the brackets are actually the same, which is very, very helpful. Okay, so now what we're going to do is we're going to take this common factor, the thing in the bracket, that's going to make up our first bracket, 2x minus 3y. And then we take the things outside, so the 2x and the plus y, and that's going to make our second bracket. So probably the most confusing part, this 2x plus y, that comes from this y here and this 2x here. That's where those terms come from. And that's finished, and that's correct. The alternative method, let's see if I can just fit it in down here, is what I would also, the way I tend to approach it, is I'd set up my double brackets. I know to get -3y squared that we need to have a y in one bracket and we need to have a 3y in the other bracket. It's not entirely clear where the plus or minus goes, but we know one's plus and one's minus. We just don't know which way round. we have 4x squared. Now, because this is quite a low b term compared to the 4 and the 3, that's something you get by intuition. This 4x squared is probably 2x times 2x, so it kind of balances more. That's a bit vague, but that's the way I tend to think about it. So it's probably 2x here and 2x here, and then all we have to decide is where the minus goes. Well, you can do that by trial and error and try it out, but then you'll get that's a minus and that's a plus if you try it and see if it works or doesn't, as the case may be. So that's the two ways of doing it. We've got splitting the term on the right hand side, and then that more intuitive way of trying a few things out, see what's happening with those middle terms to make sure you've got the right factorization. Okay, both methods absolutely fine, just go with what feels good for yourself. Okay, so quick check of the mark scheme, examiner's report. So there's the mark scheme. They might have even approached it in a different way. I did it like the way down below. If we go to the examiner's report, a majority of candidates score full marks. That's quite impressive. I would imagine that's a very difficult question, but I think it shows a lot of students did very well on this paper, so well done them. And some didn't get any marks at all, which is a bit of a shame. You can at least set up your brackets and try a few things out. Right, on to our last question, which actually isn't that difficult. It's just keeping focused and knowing what to do for your marks. So, write as a single fraction in its simplest form, n plus 1 over n minus 1 minus n minus 1, n plus 1. Okay, so we want a common denominator first of all. So that's going to come from multiplying these two things together. Now remember, think of this in terms of brackets. Okay, we don't tend to write it in fractions, but that's going to help us visualize what's going on. So our common denominator is going to be n minus 1, n plus 1. So that's going to be our common denominator for the entire rest of the problem. So once I've written that down, that probably is not going to change unless there's a cancellation. Okay, so that's always going to be our denominator. Now to work out what goes in the numerator, a bit like, which question was it? Is that fraction question we did earlier? There we are. We're going to do this sort of cross-multiplying idea to work out what goes in the numerator. Now, what works for numbers also works for letters as well. So, we're going to do n plus 1 times n plus 1. So, we're going to cross-multiply this way, and we're going to cross-multiply that way. So, we get n plus 1, n plus 1 minus, remember that minus refers to the entire calculation I'm just writing down now, n minus 1, n minus 1. Okay, looks a bit messy. Let me draw a longer fraction line. But you just have to work through it nice and logically. So, right, got my hands ready. Let's go. Let's see how we're going to do this. So we've got, if we multiply this double bracket out, I'm not going to go through all the details. We have n squared plus 2n plus 1. So that's this part here, like so. I'm going to put this in brackets for the moment, minus, open brackets, and we expand this out as well. So we get n squared minus 2n plus 1. Now that's plus 1 because minus 1 times minus 1 is plus 1. And the denominator is going to stay the same. Okay, so I'm just going to write dot, 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 because I'm not going to keep writing that out. Now this is where we have to be very careful, because this minus is going to switch all these signs to its opposite. So what we get is we get n squared plus 2n plus 1. That stays the same. Now we get minus n squared minus 2n is plus 2n. That's important to remember. 2n, and then minus plus 1 is minus 1. Okay, so, and we get the same denominator at the bottom, we get the dot dot dot, as I'm going to call it. And now we look at the numerator and see what we can cancel. So n squared minus n squared is 0, so that and that cancels. 1 minus 1, well, that also cancels. And then we get 2n plus 2n, well, that's equal to 4n. And we've still got that denominator that hasn't changed in the entire question. So we've got n minus 1 at the bottom, n plus 1. And we are finished. That's the solution. 4n over n minus 1, n plus 1. Okay, now the mark scheme might have expanded out the bottom as well. I doubt it, but it is definitely possible. And it has, yeah, it's actually expanded that out as n squared minus 1. But you can also leave it like I did too. So 1 mark for common denominator, 1 mark for getting these two expressions, and then the third and fourth mark come from minusing it correctly. Okay, so for a last question on the paper 2, that's quite a nice question. It's just working through algebra, it's not particularly tricky. There were a significant number of fully correct answers. I'm not surprised. It's just working through your algebra and being competent with that. Okay, so that is paper 2-2. I know a lot of people mentioned about paper 4. I haven't forgotten. I will do a paper 4, but I might have to split it into 2 parts because those papers are quite long. And with the GDC parts as well, I'll have to think about how to explain the GDC elements of those papers too. So I'll keep that in mind as well. Okay, hope you enjoyed it. I hope you've now gone through paper 2-1, paper 2-2, paper 2-3 from last year's 2018 May-June. So hopefully that gives you a good setup then next year. If I get time, I hopefully will try and do the November 2018 papers as well. So you've got plenty of material to go through before your exams. Okay, bye-bye for now.